Let's take a look at this problem. We want to solve u plus 4 is equal to square root of 5u plus 14. Now this is a radical equation. So solving radical equations, step 1. Get a radical by itself. And I'm going to put in here, do not create a fraction. And we'll talk more about what do I mean by radical by itself. Step 2. Raise both sides to a power equal to the index. Step 3. If more radicals, go back to step 1. Step 4 is solve for x. And that's kind of vague, but it could be a linear equation at this point, it could be a quadratic equation. And let me put that here. Could be a linear equation, and then you use your 4 steps for solving. Or it could be a quadratic equation, and use zero factor property. Zero product principle, if you want to do it by that name. And then step 5 is check your answers. And make this a little bit smaller so you can see all of it on the screen one time. One more time, I guess. Hopefully that isn't too small. Okay, so let's take a look at this problem. We get u plus 4. And I'm not going to put u's. I like x's. My u's look like 4's. So, okay, x plus 4 is equal to square root of 5x plus 14. Step 1. Get a radical by itself. What I mean by that is you want the radical by itself on one side. Nothing in front of it, nothing after it. You just want, for example, the square root of something, which that's done in this problem. Step 2. Raise both sides to a power equal to the index. Now remember, your index is whatever number's in this slot right here. And if you don't have a number in that slot, then by default your index is 2, which means we're going to square both sides. So we got x plus 4 squared is equal to the square root of 5x plus 14 squared. Now over on the left side, x plus 4 squared is x plus 4 times x plus 4. We can't just square the x and square the 4 because the plus in there. That's what messes it up. Now over on the right side though, when your index matches the power you're raising it to, they cancel each other away, and we're left with what's underneath the radical. So we got 5x plus 14. Now over here we'll multiply these together. FOIL, if you learned that technique. So we'll take the x, multiply times the x, multiply times the 4. And we'll take the 4 and multiply times the x and times the 4. So we got x times x first, x times 4 outer, 4 times x inner, and 4 times 4 last, equals 5x plus 14. X times x is x squared, x times 4 is 4x, 4 times x is 4x, 4 times 4 is 16, equals 5x plus 14. And always combine together like terms in a step. 4x plus 4x is 8x. So we got x squared plus 8x plus 16 is equal to 5x plus 14. Step 3. If you have more radicals, go back to step number 1. We don't have any more, so we'll go to step 4. Solve for x. Now specifically this one is a quadratic equation, and it tells us to use the zero factor property. The reason why it's a quadratic is because we've got an x squared. With the zero factor property, you want to get 0 on one side. So I'll take the 5x, move it over, and I'll take the 14 and move it over. Remember, when you move anything across or equals, your sign changes. So we've got x squared plus 8x minus 5x plus 16 minus 14 equal to 0. Anytime you take anything across or equals, your sign changes. 8x minus 5x is 3x. 16 minus 14 is 2, equal to 0. Now we want to factor this, and I'm going to use the PSD. You may have learned a different technique in your course. Here we have x squared x, no number in front of our x squared. So that's what tells us to use the PSD. With the PSD, we take the number at the end, ignoring signs. So take the 2, and we come up with our 3 columns. P column, S column, and D column. Now the P column is all the products that give you 2. Well, we got 1 times 2, and that's it. The S column, we add those numbers together. S for sum. 1 plus 2 is 3. And the D column, D for difference, we subtract smaller from larger. 2 minus 1 is 1. Now the number we're always looking for is a number in our middle term, which is a 3, which is right here, which means we're going to use 1 and 2. Now our larger number in the P column that we're using, which is 2, will always be the same sign as the middle term, which in this problem is a positive. Number I circled in the S column, S for same signs, both positive, both negative. So if this one's positive, this one has to be positive. Now zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x plus 1 equal to 0, and I'll set x plus 2 equal to 0. And we get x is equal to negative 1, and x is equal to negative 2. Maybe. We have to check them. And I'll actually write this out this time. Okay, so let's check x equals negative 1. We're going to plug that back into our original equation. So we got negative 1 plus 4. And this is not an equals at this point. This is a question mark on equals. We're wondering if that's true. Square root of 5 times negative 1 plus 14. Well, negative 1 plus 4 is 3. And we're wondering if that's equal to 5 times negative 4, or 5 times negative 1 is negative 5, plus 14 is 9. And square root of 9 is 3, so that one checks. So that answer works. Well, let's check the x equals negative 2. We'll plug negative 2 in everywhere we have an x. So we got negative 2 plus 4. And this is a question mark. We're wondering if that's equal. And we got 5 times negative 2 plus 14. Negative 2 plus 4 is 2. We're wondering if that's equal. 5 times negative 2 is negative 10, plus 14 is 4, so we've got square root of 4. And square root of 4 gives us 2, so that one checks. So both of those are our answers for this problem.